From the moment I'm up, it's incredible. Yeah, feeling magical. Magical. It's about that time. I say what? Baby, rise and shine. I'm all about that, Yeah, I can feel it. It's about to be a good day. Yeah, I'ma kick it like I never had a bad day. Keep my chin up, stand tall. Mama always said like, stand tall.
What's up, everybody? I'm Crazy Aunt Lindsay, and you are in the Fab Lab. My Fab Lab professors today are Mila and Luca, and we're having a tea party!
Crazy Aunt Lindsay, what does tea have to do with science?
I'm so glad you asked, Luca. Tea parties aren't just super fun, they're also fabulous opportunities to introduce ourselves to some key concepts in chemistry, community, and make connections to cultures across the world. In this episode of the Fab Lab, we're going to brew and steep herbs and leaves, turn flowers into flavored syrups to enhance our sensational concoction. We'll make tea party treats, scones and butter the Fab Lab way to complete our luxurious laboratory spread as we explore the medicinal history of a sweet cup of tea. We'll take a break with martial arts inspired active hour and of course, pop by the Fab Lab library to pick up my favorite new kid book club book, Love in the Library, a story about how the author's grandparents met and fell in love during Japanese internment here in the United States during World War II. You're invited to the Fab Lab Tea Party because science is fabulous. The Fab Lab with Crazy Aunt Lindsay, starring real kids from Portland, Oregon. Brought to you by OMSI, this beaker of water, and a team almost entirely made up of neurodivergent creators. Because science is fabulous and also for everyone. Science says that we learn best, not just when we're having fun, but also when we're relaxed. We're gonna take the Fab Lab heartbeat together to prepare our hearts and minds to learn more about chemistry. Close your eyes, put your hand over your heart, blow your breath out, and breathe in on a count of 4 with me starting now. 3, 4, hold. 2, 3, 4, exhale. Hold. My affirmation is I am focused. As someone who was diagnosed at a really early age with ADD, ADHD, the one thing that's true is I have always had a really hard time staying focused on one task or one subject. That's probably part of why I'm so fun at science. But to help me to remember to stay focused, I use the acronym. Follow one course until successful. I am focused.
I can do anything.
I'm ready to do some chemistry.
Let's learn about some chemistry. Chemistry is the study of substances, the stuff that makes everything up. Atoms, matter, molecules, chemicals, and how they all interact or behave together. Tea making is a super scientific way to see all of this in action, as tea making creates a solution. A solution is a homogeneous or uniform mixture of 2 or more substances on the tiniest molecular level. To make a solution, you need 2 things, a solvent and a solute. Water is a solvent, and a magical one at that. Now, a solvent is a substance that dissolves or disperses other substances. Water is a clear chemical substance made up of 2 hydrogen atoms and 1 oxygen atom. H2O is what its molecules are called. A single drop of water contains billions of these H2O molecules. It can be found in its solid or ice, liquid, or gas vapor form, and makes up all of our seas, lakes, clouds, and more than 70% of our bodies. This is why we need it, and most cultures see it as sacred, or a very, very special substance. Tea creates a solution that's 98% water and 2% compounds released by the act of steeping dried organic matter. unlocking the powerful essences or molecules from deep within the leaves, herbs, and even fruit. When dried tea leaves come into contact with water, they become rehydrated, absorbing or sucking up moisture. We call lots of liquidy libations tea, but the real thing comes from one plant, the Camellia sinensis. In today's project, we're going to use what we have on hand to infuse, dissolve, and create some tasty concoctions to experience and ingest some of the magic of chemistry on our own. But people have been studying tea for a really long time, making important discoveries along the way. One such person is Japanese biochemist and history-making educator Michio Sugimura, the first woman in Japan to receive a PhD or doctoral degree in agriculture. Sugimura Sensei conducted groundbreaking research and made discoveries into the nutritional and medicinal benefits of green tea. Sensei means professor in Japanese. She was a science teacher earlier in her career, but she had always dreamed of becoming a scientific researcher at Hokkaido Imperial University, which she achieved. Well, kind of. At the time, they didn't accept women, but she was able to take an unpaid assistant research position where she analyzed the nutritional benefits of the Japanese silkworm. She later transferred to another school to work with famed doctor Umataro Suzuki, who discovered vitamin B12 in green tea. Later, they discovered vitamin C, the first of many yet known compounds in green tea. She then isolated catechin and tannin, the bitter ingredients in the tea leaf, and in 1932, submitted it as a part of her research for her doctoral thesis on the chemical compounds in green tea, graduating her as the first woman in Japanese history to earn a PhD in agriculture. She would later make education history by becoming the first dean of home economics at Tokyo Women's Higher Normal School in 1950, the very place that she'd been a student years before and developed her interest and passion for the scientific career she has, thanks to the help of her teacher and accomplished biologist, Yono Yasui, the first woman in Japan, period, to receive a doctoral degree in science. You should really look her up. Visit thefablab.com for more. Come with me to OMSI to meet my friend Eva, an OMSI educator, to learn more about chemical reactions. Hello.
Hi.
What are we doing here now?
We are going to find out why water is so good at mixing with some things.
Ooh, I heard it's because it's the most mysterious substance on Earth.
Yeah,
And that means it mixes with a lot of stuff.
there's a lot of stuff that really likes to mix with water. Things like sugar for sweetening your tea.
Yes.
Things like the tea that you're soaking in the hot water to make your
Yes.
tea. Things like salt and a really stinky gas called ammonia.
Ooh, that makes me think about my grandma cleaning on Sunday mornings. Ammonia is a colorless, super stinky gas that has a sharp, suffocating odor. Its molecular name is NH3. I remember it as an old school cleaning solution my grandma would use to get stains out of clothes or degrease the stovetop. It can even be found in hair products and fertilizer. That's what my dad used in his garden. You don't want to drink it though, because it's very poisonous. Its smell serves as a warning.
Yeah, ammonia loves water so much, and that's why it's so stinky, because we are made out of a lot of water. And so that ammonia goes in our nose, goes in our mouth, and sticks to that water and just becomes a stench fest in our noses. Yeah.
Okay, so what is this contraption?
Yeah, this is our ammonia fountain.
Ooh,
Yeah.
and what are we gonna do with it?
Well, in this container, I have some normal water, and I have an indicator called phenolphthalein.
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 By any chance, is it connected to pH?
It's totally connected to pH.
Nice.
pH is about telling us how much acid or base something has.
Most liquids are either an acid or a base. Acids tend to be clear, taste a bit sour, and have lots of hydrogen ions. You can find natural acids in your home, in orange juice, lemon juice, which we'll use in today's episode, but also in our tummies. Bases tend to taste bitter and feel a little bit soapy or slick in texture. They have hydroxide ions, and you can find these in plant fertilizer, toothpaste, and baking soda. It's not always easy to tell the difference between an acid and a base just by looking at it, which is why we have the pH scale. acids and bases can be used to neutralize or calm one another down. You can see this in action by their color change. Okay, so what happens next?
Well, first, let's check out this water. What color do you see in this container with the phenolphthalein right now?
It looks bright clear.
Yeah. Phenolphthalein doesn't do a whole lot with neutral things like water. It just kind of stays clear. But when it meets bases, it does something exciting. Are you ready to see what happens?
I am so ready to
when
see what
ammonia
happens.
meets water and phenolphthalein?
Yes, please.
All right, you've got your goggles on. We've got our
my
lab
goggles on.
safety to protect our beautiful, precious
We
eyeballs.
do.
Do you want to give that bulb a big squeeze?
Absolutely.
I'm gonna hold this tube in here.
Yes.
Isn't that beautiful?
That's beautiful. That is amazing. How is that happening? What?
So ammonia loves water so much that even that little bit of water you squeezed in there, all of the ammonia gas that was filling this bulb jumped into that water. It wanted to be with it so much. And that left nothing behind in here, a vacuum, kind of, so that vacuum, just like.
all of the gas went into the water. Concepts are coming together right now. I love this.
So just like
Very
a vacuum
cool.
cleaner sucks things up, the
Yes.
vacuum in here sucked whatever it could up, which happened to be the water in the bottom of the speaker. And that's how we got that cool fountain effect.
So nothingness sucks somethingness into activity.
Yeah.
Very cool. Ebeth, this was fabulous, but we can't drink it. Meet me in the fabulous laboratory where we're going to use butterfly pea flowers to make a similar outcome, but one we can ingest. There's the science. Now let's make it fabulous. Welcome to the Fab Lab Tea Party. So we have a couple of things going on here. We've got about 3 different types of teas and herbal tea. As we talked about earlier, tea is technically made from one plant, the Camellia sinensis, but you can totally make herbal teas. Tea has a long history of being used as a medicine, again because the water is a solvent and can pull out all of the nurturing, nourishing, and health benefits from the polyphenols and flavonoids. A flavonoid is a polyphenol found in plants like leaves, fruit, and vegetables. We're going to do a whole spread to introduce ourselves to the different compounds and properties of all the different types of tea that are available. We have black tea, green tea, chamomile tea, turmeric tea, and one of my favorites, blue pea flower. No Camellia sinensis in this. Alrighty, we also have, do you remember what these are? What's this?
That's a sugar there.
Do you remember what kind of sugar?
Just plain sugar.
Do you remember what kind this one is?
Raw sugar.
Nice. Do you remember what that is?
Salt.
Who remembers what this is called?
It's called, I forgot.
Really? You don't remember?
No.
Molasses. This was my granddad's favorite. It's old and southern and a little difficult sometimes. Honey, correct. Do you remember what this one is? Agave!
Oh.
Say it with me. Agave! Nice. So which tea do you want to try first, just for fun?
Wait, can we try this one first?
You want to try the blue pea first? Heck yeah, we can try blue pea first. And our water is just ready. Who wants to add the blue pea flowers? Go for it, both of you. I'm so glad the kids chose blue pea flower to work with for our tea party because it doubles as a magic trick that helps us to observe and taste the acid-based pH chemical reaction. First, make sure you have an adult on hand to help you with this project because the water is boiling hot and could hurt us if we're not careful. We're going to safely observe the incredibly gorgeous steeping process, thanks to the abundance of anthocyanins, the water-soluble pigment that gives this beautiful botanical its deep blue color that lives in the flower's petals.
It's happening.
It's happening! Okay, guys, it's actually happening. It's happening. Oh my gosh. It's actually happening. We'll use lemon for our magical tea party trick, but see what happens when you use a slice of orange, cucumber, or even just a splash of seltzer water. Awesome! So this is really great because now we can see what it looks like when our blue pea flour has no acid in it, when our blue pea flour has lots of acid in it, and when it has just a few drops of acid. Okay, I'm gonna give mine a taste. Do you wanna give yours a taste?
Yeah.
All right. Cheers! Now we're gonna do one of my favorite ways to observe the difference between dissolution or dissolving and infusion. We've got our teas that are steeping in their Fab Lab beakers. And the next thing we're going to do is take our flavorings and dissolve them into their water. Nice.
It kind of changes the color.
Let's see what happens.
They sort of like kind of.
They turn smushy.
I'm gonna put a little bit of hot water in our honey. Nice.
Oh.
Let's grab a Fab Lab spoon. See how long it takes to dissolve.
I don't know if it's salty.
It looks like water now.
Yours dissolved super fast. You're gonna grab a little bit like this, and you're just gonna drop it like that. Nice. Sugar, honey, perfecto. I'm using this simple sheet of white printer paper to make the Fab Lab drip sheet. On one side, I'm going to write infusion. On the other, dissolution. We'll drip some of the unsweetened tea onto the infusion side to see what happens when it dries. Now watch what I'm doing. I'm gonna take my Fab Lab spoon and then I'm gonna taste it. Very bitter. Okay, we're gonna let these dry, and the next time we see it, we'll know the difference between infusion and dissolution. No tea party is complete without a tasty little treat, which is why we're going to make Fab Lab scientific scones. We're making Fab Lab scones. You ready?
Yeah.
All you need for this recipe are 2 cups of your favorite flour, a half a cup of sugar, about half a teaspoon of salt, and incorporate those dry ingredients. Now lob a few healthy tablespoons of Fab Lab butter, a splash of milk, and knead.
I think this is sort of cleaning your hands.
Yeah, it is kind of cleaning our hands.
See?
Okay. Now roll and cut your dough into your favorite or simple shapes. Doesn't need to be perfect, it just needs to be fabulous. Like these little triangles. Pile them onto a baking sheet and pop them in the oven for 18 to 20 minutes. And now we bake! Our scones are all set. Now it's time to make a super scientific Fab Lab drizzle. The Fab Lab lemon icing we're going to use for this project is also super scientific. All you need for this is about a cup of sugar and 3 healthy lemons. Squeeze your lemon juice into your sugar and watch the Fab Labulous magic happen as you whisk. You want to pour a little bit on each one? Alrighty guys, our Fab Lab scones are all done. We're gonna set these aside for the Fab Lab Tea Party that we're gonna throw later. But up next, Fab Lab Active Hour. Sounds like Fab Lab Professor Nile has arrived. That means it's time for Active Hour. This week, we're playing one of my favorite playground games that I used to play when I was your age, Ninja. Ninja are the Japanese secret agents in medieval warfare, tasked with finding out facts, clues, and stealthily infiltrating the opposition. This game is inspired by ninjutsu, one of the martial arts that the ninja had to master. Let's play. To do this game, it's super easy. All you have to do is get your friends into a circle. One at a time, you're going to stick your arms out and take a ninja stance. Then, one at a time, you're going to strike and try and hit one of your teammates from their shoulder to their wrist. And if you touch them, then they have to put their arm behind their back, and they've only got one to fight with.
Ow.
Ready? 1, 2, 3. Yeah! I'll go first. Did you know that the word ninja, according to the rules of the Japanese language, is already plural, meaning a group of individuals? When we add an S to make it sound more like English, we actually say the word incorrectly in both languages. A super easy way to more fully honor the cultures we're learning about and appreciate them is by embracing their linguistic rules, prioritizing the saying of things according to their correctness and not our comfort. Okay, so it's me and you. Sorry. Oh! Nice. So you do that a few times, you work up a sweat, and then you go have whatever your favorite snack is. I'll see you in the next one. Nice. Thank you, Niall. Ooh, Love in the Library by Maggie Takuta Hall. Illustrated by Portland local illustrator and jiu-jitsu enthusiast, Yaz Imamura. This gentle, loving true story takes place in an American-Japanese internment camp in Idaho, where Tama is sent to live during World War II. Missing her home and former way of life during senseless captivity, our main character takes refuge in the color, light, love, fairness, and justice bursting forth from the stories and the books that she finds in the camp's library. She's joined by her friend George, who always seems to be around, but never seems to be reading. We find out why in this deeply loving, hopeful, and beautifully illustrated children's book about love, history, and miracles. To fall in love is already a gift. But to find love in a place like Minidoka, a place built to make people feel like they aren't human, that was a miracle. And that miracle, the author's grandmother and the subject of this lovely story writes, is in all of us. Read this story with me in an upcoming Fab Lab bedtime wind down story time by becoming a Patreon patron today. Also, make sure that you follow us on Instagram Live, where we're often joined by authors and illustrators of the books that we feature here. To learn more about this book and many others, visit the Fab Lab library shelf at thefablab.com. All right, you ready for some tea?
Yeah.
I'm coming in hot. I'm gonna do Mila's tea first. Ooh. Do we want to put a little bit of lemon in our magical tea brew? Yeah. Yes. Uno, dos, tres. What you're observing, friend, is a chemical reaction. There are flavonoids inside of the blue pea flower that react with the vitamin C and turn this beautiful purple color. Tama did not like the desert. She brushed the dust from her eyes as she walked to the library. The barbed wire, fences, and guard towers cast a long shadow over her path. She always did her best not to look at the guards. Tama had taken the job in the library because she liked books. She didn't know how to be a librarian, but that didn't matter. In the camps, people did jobs that needed doing, and that was that. Growing up, my family started the tradition of writing thank you notes to guests for coming over and often bringing gifts whenever they did. I'm gonna say thank you to water for being such an incredible mystery to scientists. Thank you for your surface tension and expanding when it gets cold. But I'm especially going to say thank you for being a solvent and releasing all the powers of leaves, bark, fruit, and other plants so that they can nourish my body. I'm gonna say thank you to Michiu Sujimura for her incredible research and hard work, becoming the first woman in Japan to earn a PhD in agriculture. I'm gonna say thank you to the humble little tea leaf for opening up a world of deliciousness and nutritiousness. Love, Crazy Aunt Lindsay. I'm also gonna say thank you to you and me for joining me this week, because science is fabulous. Thank you to OMSI, the Marie Landrum Foundation, and the entire Fab Lab community of patrons on Patreon and iFund Women for making this entire season of STEM programming possible.